previous meeting, we presented the lesson 5, gravimetric analysis and its subtopics. And now it's time to move forward into the next topic, which is the lesson 6, monotropic acid-base equilibria. But before that, this is our objectives. And our conceptual framework. Without further ado, let's start our discussion.
Good day, folks. My name is Michael, and today we will go into chapter about acids and bases. So acid and bases are popular chemicals which interact with each other, resulting into the formation of salt and water. The word acid came from the Latin word acere, which means sour. In everyday lives, we use many compounds which scientists call it acids. The orange juice that we drink, the milk that we drink, there is the presence of acids. So, what are acid and bases? So, an acid is an hydrogen containing substance that is capable of donating proton to another substance. And a base is a molecule or ion that able to accept a hydrogen ion from an acid. So take note, if it is so many hydrogen ion, then it is acid. And if it is so many hydroxide ion, means it is base. So we have this example for acid and bases. So we have HCl and HF, and for base is we have NaOH and KOH. So whenever a hydrogen has a positive charge, it means it is acid. And whenever a hydrogen has a negative charge, it means it is a base. In Arrhenius' definition of acid, acids produces H plus ions into the solution, while base produces OH negative into the solution. So acid is the H plus donor, while base is the proton acceptor. So let's have an example. So this one. So our base is the NH3 and our acid is H2O. So we have the conjugate acid, which is H4 positive charge, plus we have the conjugate base, which is OH negative charge. So we called it conjugate acid because we added H plus, and we called it conjugate base because we took away hydrogen. Now, to find out the conjugate acid and the conjugate base, this is how it goes with. So let's have an example for H2O. For conjugate acid, we need to add H plus, and for the conjugate base, we need to took away one H plus. And that's how we go for conjugate acid and conjugate base. That will be all. Thank you.
Hey everyone, I am Christine Alay, and my topic is all about acid-base equilibrium. We need to understand that acid-base is just a reversible reaction and eventually achieve equilibrium. We can really understand what is going on in an acid-base by measuring the equilibrium constant, and equilibrium constant is equal to K, where concentration of the product divided by the concentration of the reactant. So what is acid or base? Remember that it all relates to proton exchange. If you donate protons, it is acid. And if you accept protons, then it will be a base. So we can measure equilibrium constant of acid bases and determine if they are strong or weak, and we can also combine acids together, and then it is called neutralization reaction. First thing you should understand is the importance of water in all acid-base takes place in the presence of water. So we can think of an infinite amount of the water surrounded every acid or base, something that we can simply ignore. There's always going to be a water. So what's cool about water is it can auto-ionize. It means it can serve both acid and base. So take a look at the reaction. H2O plus H2O, the product will be H3O plus OH negative. What are we going to do is donating the proton to another water molecule. If you look at the illustration, we are forming hydronium, and the one that loses proton is going to be hydroxide. And we can measure the K value of this is equal to K is equal to 1 times 10 to the power of negative 14, which is a very, very small value. So remember that equilibrium constant is the concentration of the two product divided by the concentration of the reactants. In this equilibrium process, we can ignore water because there is always water present. So this is now the value of our equilibrium constant. Then we can just figure out that equilibrium of hydronium and hydroxide must be 1 times 10 to the power of negative 7. Therefore, pH, which is negative log of the hydronium, is 7. It is easier to deal with it in that way because it is a small number. Likewise, in POH, 7 as well. So if we add pH to POH is equal to 14. Now, what is the difference between strong and weak acids and bases? Well, the equilibrium constant will help. If you look at the acidic acid, in this case, it's donating protons to water. So we can figure out its acid ionization constant. If we write it out, the value of our Ka, which is equal to concentration of the product divided by the concentration of our reactants. So the value is 1.76 times 10 to the power of negative 5, which is very small number. It means that the reactants don't really donate protons, and it is called weak acid because the Ka value is less than 1. We can also identify that it is a strong acid if the Ka value is more than 1.
Oh, thank you, Miss Christine. Now let us move on to 5.5 gravimetric calculations. We have the different calculations or formulas to be used depends on what is asked in a given problem. We have the formula if the amount of analyte is being asked. We have also the formula in finding the percentage of analyte in a given sample. And the formula in finding the percent by mass of analyte in a sample. So now we have a sample problem in calculating the amount of analyte in a sample. Calculate the amount of boric acid from borax. We have to balance the equation. Next is calculate the molar mass of analyte and precipitate. Lastly is the final calculation wherein gravimetric factor is equals to the moles of analyte over precipitate multiplied by the molar mass of analyte over molar mass of precipitate. So the answer will be 0.648 grams of boric acid. Now let's proceed to 5.6, volatilization and particulate. Volatilization is thermally or chemically decompose the sample and measure the resulting change in its mass. We have thermogravimetry, which is a process that monitors the sample mass as a function of temperature. This shows a typical thermogram in which each change in mass represents the loss of a volatile product. The equipment in volatilization depends on the method of analysis, either simple or complex. This is the instrument for conducting thermogravimetric analysis, which is the electromagnetic balance. Volatilization gravimetric methods continue to play an important role in chemical analysis, like in organic analysis and organic analysis. Volatilization gravimetric methods are time and labor intensive. Equipment are needs few except when combustion gases must be trapped. On the other hand, in particulate gravimetry, we simply need a method for collecting the particles and a balance for measuring the mass. There are two methods for separating a particulate analyte. First is filtration, in which we separate solid particulates from their gas, liquid, or solid matrix. Second is extraction, that is useful for gas particles, solutes, and solids. Particulate gravimetry is important in the environment analysis of waters, air, and soil samples. The analysis for suspended solids in water samples, for example, is accomplished by filtering an appropriate volume of a well-mixed sample through a glass fiber and drying the filter to constant weight of 103 to 105 degrees Celsius. Consequently, particulate gravimetry is easily extended to the analysis of trace level analytes. Particulate gravimetry uses the same balances as other gravimetric methods and is capable of achieving similar levels of accuracy and precision.